So this is something we've sort of been doing implicitly this entire time we've been talking about polynomials, but I think it's nice to make particular statements about how to do this. So there's what I would call like the freshman's dream, right? Kind of the naive approach to doing this, which is here, right? So I'll say that this is natural but naive, and this is correct. And the point is that if I want to multiply two linear factors together, I have to distribute the first term to both things here, and this has to go to both of these things here. This picture here is saying that AX only goes with CX and B only goes with D. But that's not how multiplication of sums works, right? This is not following our order of operations. Okay, so this is just a simple illustration that we have to be a little bit careful in expanding polynomials. So let's look at a few examples to check how this might be assessed on the clip. So here's something that we have already looked at in our previous examples. If I have two linear terms, rather factors, how do I multiply them together? Well, I simply take x and I multiply that by 2x. And I also multiply x by 3. Then I move on to the second term of the first factor. So minus 7 hits the 2x. And then it also hits the 3. All right, and now all I have to do is simplify everything. So x times 2x becomes 2x squared. 3x, I mean, it's more customary to write the number first and then the variable. Minus 14x, and then minus 21. So 2x squared minus 11x minus 21. Okay, so expanding you can think of as just the opposite of factoring. Okay, in this case, I think it's not too bad, but of course one can expand products of polynomials of degree higher than 1. We can look at products of quadratics of degree 2 polynomials. So let's conclude this section with a more complicated example like that. Okay, so here I have two degree 2 polynomials, and I'd like to multiply them together. So this is degree 2, and this is also degree 2. Okay, so how does this work? Let's say that this is equal to x squared times x squared. So I'll send this guy to all three of them. So plus x squared times 2x plus x squared times 2. And then I'll play the same game for the minus 7x and the 1. So and now I have to just deal with the 1 here. So plus 1 times x squared, 1 times 2x, plus 1 times 2. And then the matter of simplifying everything is a task in and of itself, unfortunately. Just have to kind of make everything look a little bit nicer. So I have x to the 4th here from this guy. And then x squared times 2x is 2x cubed plus 2x squared minus 7x cubed minus 14x squared minus 14x. Oh God, mercifully almost done. X squared plus 2x plus 2. And then I have to combine everything together. So x to the 4th appears once. There's an x cubed here and an x cubed here. So minus 5x cubed. And where are the x squareds? There's one here, here, and here. So that gives me, let's see, minus 11x squared. X is minus 14 and 2, so minus 12, and then plus 2. So again, pretty nasty looking to start with, and not an easy computation at all. I really just have to remember to distribute everything in the first factor to everything in the second factor, and then put like terms together. All the x squareds go together, all the x cubes go together, all the x's go together. Okay, so again, I think that this looks harder than it is. You just have to take your time and make sure that every step is correct.